Hello, everyone. I have been asked to give a sort of climate today to help introduce y'all to the climate crisis and also what we can do about it, what climate action actually looks like on a concrete basis. So let me share my screen. We are in a new situation here on planet Earth. For pretty much all of human existence, we've had a pretty uniform level of carbon dioxide in the atmosphere. But in the past 100 years, things have really spiked. The last time there was this much CO2, carbon dioxide in the atmosphere, was 2.6 million years ago, when there were no ice caps, and where I'm at right now, Charleston, South Carolina, was part of the ocean floor. We are hitting new peaks every year. Here's a fun fact. There's been more carbon dioxide burnt since Seinfeld went off the air than the entire run of human civilization before then. Because of fossil fuels, because of the global economy running on coal and gas, we have been burning organic matter at a crazy high rate, and that's all going up into our atmosphere, which is sort of a problem. This is the basic mechanism of climate change, of global warming, of why things are heating up more and more every year. We have an atmosphere that encircles the Earth, and within that atmosphere, we have breathable air, we have heat being trapped, and solar energy, energy from the sun, goes through the atmosphere. Some stays and some bounces back out. But less and less can bounce back out because of this greenhouse gas effect. It works like a greenhouse, it traps heat. Who wants to guess when we as humanity discovered that when you mix carbon dioxide with atmosphere, it traps heat? You can just put a guess in the chat of what year, what decade you think we figured that out. People guessing.
We've got
1850s. Welcome, Indian people to everyone is the winner. It was the 1850s. There's two scientists, Eunice Foote and John Tyndall, who discovered a very simple scientific combination. Carbon dioxide and atmosphere traps heat. The climate crisis can feel complicated, but at its most basic, it's something that we've known for over 150 years. When you mix CO2 with atmosphere, it traps heat. So all the CO2 we were burning is trapping more and more heat every year. Uh, and unfortunately, there is a one-to-one correlation, more or less, with temperature rising and carbon dioxide gathering in our atmosphere. The graphs are the same. Um, and the departure from our historic average is getting bigger and bigger every year. And what's a little scary is that it's not even where the heating is going. A lot of it is concentrated in the north where our ice caps are, which leads to rising sea levels. The ocean is absorbing a huge amount of this heat. The ocean has really been helping us out. But unfortunately, the ocean is nearing a point where its capacity is about full, where it sort of absorbs as much heat as it really can. Um, One way to think about this is variation. So global warming, climate change does not mean that every day will be hotter, but it means that especially hot days will happen more and more often. So as you can see, we are moving from a relatively even baseline to these warmer than average and extremely hot days happening more and more often, these extreme heat days. And that's pretty dangerous, especially for those of us in the Southeast and South Carolina, because here in the South, we're pretty vulnerable to those extreme heat days. There's something called wet bulb temperatures, where the heat is so high that we can't sweat off the heat. It's a certain temperature where the human body just starts to shut down. And that's a real concern with climate change is more and more extreme heat days leading to those wet bulb temperatures that are really dangerous to human health. We're losing our aquifers. A lot of them are drying up. As you can see, South Carolina is no stranger to this because drought is a real issue with the climate crisis. You're having these longer and longer periods of extreme dryness because of that extreme heat. Wildfires are an issue. So far in South Carolina, this has not been our main climate consequence, but I'm sure y'all followed the LA fires. Colorado has been experiencing awful wildfires, and it's because of a mixture of dryness and heat, and also some extreme winds. So you mix all those things together, and you have these really, really dangerous, huge, raging wildfires. We are in danger of losing a lot of staple crops. Extreme heat is not good for plants. They can't go inside. And so things that are staples like corn, wheat, rice, soybeans are in danger of losing a lot of yield. Flood damage is an increasing issue. So here in Charleston, South Carolina, we have sort of tidal flooding as a real issue. But throughout the country, as you can see, it's not just coastal areas you're dealing with increased flooding. There's something called rain bombs that comes more and more from climate change, where you'll have a ton of water that falls all at once instead of over a longer period of time, sort of just this torrent falling from the sky. And rain bombs lead to extreme flooding. This is an example of a precipitation bomb that had almost 5 feet of hail drop in 15 minutes. Um, Weird weather is sort of what we have to expect from climate change. Um, Extreme flooding, sea level rise. So this is a coastal issue. But as we lose ice caps, that water has to go somewhere. So it moves up and up the coast. Um, we have more and more flooding days that are projected to happen here in South Carolina, tidal floods. So if we flooded 50 days a year, by 2040, we'll be flooding almost 100 days a year, and so on and so forth. And this is just a pretty scary projection of worst case scenario for us here in Charleston, South Carolina. Hurricanes get more dangerous, more powerful when they have more warm water to move over. So as the oceans heat up, hurricanes get stronger and less predictable. And previously, hurricanes have been thought of as more of a coastal issue, but as we saw from Helene with the upstate and Western North Carolina, we can no longer depend on hurricanes to do what they have done in the past. They're less predictable. And that's also scary because if they pick up quicker and we don't see them coming, that's where the real damage comes, is when they're unexpected. And you just have more and more storms sort of coming at the same time in one season. I think it was Louisiana a couple years ago that got hit by two in a row, essentially, which is sort of a worst case scenario. And it leads to a ton of damage. It leads to billion-dollar disasters. So this is just a graph showing how those billion-dollar disasters are happening more and more year to year. They're just adding up. Weather events that just cause enough destruction and damage. And this is using a dollar amount, but of course, as we all know, that leads to a lot of human loss of life, damage to communities, etc. We just have more and more frequent disasters. This is a graph of the days in between these massive disasters. As you can see, we're getting less and less time in between them. And displacement is going to be a real issue. So the global south is going to be hit first and hardest by the climate crisis. They're having more drought, more extreme heating, and folks are going to have to leave their homes at some point and need to go somewhere. So when you look into the future with the current projection of the climate crisis, you have a lot more climate migrants who are going to need someplace to go. And finally, humans are not the only species on this world. We are part of a web of life, and we're currently in the sixth mass extinction for a number of reasons, but the climate crisis is helping drive it. Sort of a slippery slope or a cliff edge, as this headline says, where we're going to lose more and more species if things keep going the way they've been going. So that was gnarly, huh? That was a lot of not very good news. But what I want to talk also today about is what we can do about it. Because, like I mentioned, it's a very straightforward thing that's making this happen. It's greenhouse gases in the atmosphere causing heating. And we know what causes greenhouse gases, and we know ways to build our society, to build our built environment that pollutes way less in the way of greenhouse gases. And one day we can actually start to bring down those greenhouse gases. But it takes action on every level, which is what we advocate for with the Charleston Climate Coalition. The climate crisis comes from this atmosphere pollution, leads to global warming, leads to climate change, leads to all these human and environmental consequences I just went over. But all of that comes from our imbalanced systems. And when I say systems, we like to break it down to 6 categories: buildings, waste, transportation, energy, food, and nature. And so I'm just going to hit these pretty quickly. We have a more in-depth version, but this is sort of the basics of how we see climate action actually playing out. So buildings. Buildings are a big contributor to climate change through everything that goes into making them: mining and logging, manufacturing, installing them. I see there's a little bit of cutoff on this slide, but that word there is embodied carbon. That's the concept of when you look at a building, you can say there's this much carbon that had to be used to make that building. And then there's all the energy usage of the building once it's been built. A building is always running AC or heat. The lights are on a lot of the time. When you think about a hospital or a school, it's kind of like a car that's always idling, always running. That uses a lot of energy. So what can we do? Well, we can build greener. We can use organic building materials like hempcrete, rammed earth, adobe. There's a new nonprofit in the Southeast called Root Down Building Collective that's all about pushing forth these organic building materials. They recently got an EPA Community Change Grant to build some green affordable housing here in Charleston, which is really exciting. We can incentivize green buildings. So making sure when buildings are built, they're energy efficient. They have things like green roofs where you have some plants on the roof, which helps absorb stormwater, helps lower the need for AC and cooling. And you can have more climate-friendly zoning. So instead of having sprawling suburbia, which leads to both a lot of inefficient houses and people being spread and having to drive a lot, you can have more mid-sized development, plan for resilience, so building on high ground, having all the amenities you need, where you work, where you play, where you eat, having that be closer to where you are. So the way we design cities can just lead to fewer emissions. And weatherization is always really helpful too. So weatherization is when you go into a low income house and you seal the building envelope so you're losing less heat and less AC. So the energy usage of the house can go way down. Weatherization is a great program that can help reduce emissions, save people on their energy bills, and just help them live a little better. Transportation. So transportation is mostly cars. So cars run on gasoline, and the fact that we have built our society around cars means that there is a whole bunch of climate pollutions coming from these cars. So you measure that in VMT, or vehicle miles traveled. And the thinking with climate action is anything you can do to reduce the average VMT of a city, you're reducing your greenhouse gas emissions. So having alternatives to cars is really important. So having a bike lane network that's actually connected, where you feel like you can safely get from point A to point B without sort of losing that path and that connection, that's really important for folks feeling like biking is actually an alternative to driving their car. Having a robust public transportation system. Here in the South, we usually have buses as our main form of public transportation. Other places have light rail. Maybe one day we'll have that too. But having that public transit is really important. And pedestrian-friendly spaces. So feeling you can walk places without, dealing with heat because there's no tree canopy keeping you cool, or the sidewalk just ends and here you are on the interstate. Having that pedestrian-friendly design is really important too. And then lastly, electric vehicles, because they pull from the grid and not inherently gasoline, are cleaner too. Waste. So everything that we consume is from materials that had to be mined and gathered, from energy that had to be used to actually put it together. So anything you consume like clothing, toys, appliances, that all sort of has a cost. And disposal of waste leads to landfills that leak methane, which is a really potent greenhouse gas. So how much you use is part of this. So there's that reuse, reduce, recycle idea where, ideally we have sort of a circular economy where instead of throwing things away and buying new things all the time, we have a closed loop in our own community that can really be helpful. And also, when possible, recycling, especially the very recyclable things like paper, glass, aluminum, and also composting is really helpful. Nature is a nice one because nature actually helps us. Nature doesn't hurt us. Um, Natural resources like wetlands and forests absorb CO2. Humans, we breathe in oxygen, we breathe out CO2. Plants are the opposite. They breathe in CO2, breathe out oxygen, and they sequester CO2 in their root systems. So everything we do that protects our forests, protects our wetlands, maybe puts in new trees, is helping draw down carbon dioxide from the atmosphere. So it's sort of a defense mechanism, nature's defense mechanism. The more we protect, the more we help support that. Food systems are interesting because in terms of individual actions, we usually point people with our organization towards collective actions, sort of doing things for a community through the local government, through the county government, these bigger scale actions. But when it comes to, oh, I want to change one part of my lifestyle to be more climate friendly, when people ask me what they can do, I tell them that actually reducing meat consumption is a big one. Doesn't mean you have to go completely vegetarian, but fewer meals a week where you use meat is helpful because especially the beef industry, the cattle industry, is a huge climate emitter when you really add it all up. Um, Also, composting, again, is a surprisingly helpful tool. And finally, energy. So part of the reason why we're at where we're at is because of global energy consumption, mostly being dirty fuels. So gas, fracked gas, also known as natural gas, is a huge one. Coal is a huge one. Um, and the more that we can take that off of our grid and replace it with renewables, like solar panels, like wind energy, the more that all the energy we're using is not actively fueling the climate crisis. And so pushing our utilities to do something different is pretty important.